Alright, welcome. This is 7.3. So let's go through this really quick. So put 7.3 at the top. So our essential understanding, you don't need to write this top, but what we're trying to do in this video is to show you that two triangles are similar when you know the relationships between only two or three pairs of corresponding parts. And our essential understanding is sometimes you can use similar triangles to find lengths that cannot be measured easily using a ruler or other device. Okay, so what we are going to write down though is this right here, our key understanding. So remember when we had trying to figure out if two triangles were congruent, we said three angles are the same, three sides are the same. Well, we have these different postulates to figure out if two triangles are similar. So instead of figuring out if three sides are proportional and three angles are congruent, there are a couple shortcuts, just like angle, side, side, all those different ones. We have three of them. So here's the three. So make sure that you write down the postulate and the picture, everything inside this box. So the first one says if two angles, whoops, let's start here. Yeah, let's start with this one. This is like a newer one for us. If two angles of a triangle are congruent to two other angles of a triangle, then the triangles are similar. So again, similar, we use this little sign right here to show that these two triangles are similar. And this one right here, we'll put it off to the side one of our ways, and there's going to be three of them. This one was a new one, was angle, angle. We didn't have that one before. So that's one way to show. I'll go kind of quick, but make sure you can pause the video at any time. Let's see what another one that we have here. Another one we have is side, angle, side. So on this one, if an angle of one triangle is congruent to another angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. Okay, so the two sides are proportional, and that one angle is congruent. So here is side, angle, side. And then that means that our last one that we're going to have right here is side, side, side. So again, if all three sides are proportional, then the two triangles are similar. Side, side, side. So here's our shortcuts right here. And those are our three shortcuts to prove if two triangles are similar. Okay, so let's go through a few examples. So before I go on, just make sure you write down, we went really quick, write down the picture, the theorem, everything inside here. I know it might take a little while, but make sure you have that all written down. Alright, so our first problem, make sure you have this written down in the picture. So it says, are the two triangles similar? How do you know? So the first thing I notice is I see that I have both these angles, R and V, are both 45 degrees. So we know right here that angle R is congruent to angle V. And so again, I'll put off to the side right here, this is S right here for, I'm sorry, A for angle, not side. So we have A right here, that is an angle. Okay, and so the next thing that we got to figure out, if I can figure out one more angle, then I know that the two triangles are similar. Well, I see right here, this S right here, I'll put two lines, and here's two. I know that angle S right here is congruent to angle S because of my vertical angle theorem. So that is another angle. And again, this is one of the ones that I can use. So angle, angle, so I know that these two triangles are similar. So I'm going to write triangle RSW, and again I'm going to write that symbol for similar. It's similar to triangle, and then just got to make sure that they match up. So we said R was the same thing as V. S is congruent to S, so it's going to be S, and W is congruent to B, so we're writing B right there. There we go. This first one. Alright, so here's a problem. It says, are the triangles similar? If so, write a similarity statement for the triangles. So I'm looking at these two triangles right here, and I see I'm given all sides and no angles. So I know if this is going to be worked out, if they are similar, it's going to have to be side, side, side. That's going to be the only way. So how do I know? Is I have to find the proportions of each side, and if they are all the same, then it's similar. If it's not, then it's not a similar triangle. Okay, so again, how would I know? Because these triangles look like they are maybe rotated different. How do I know? I got to make sure I match them up. So the way I'm going to do that is I'm going to take the largest one. So the largest one right here is 15, and the largest one over here is 10. So I'm going to say this is my left, and this is my right. And I'm going to put on each of these, I'm going to put the right over the left. Doesn't really matter which way, I just have to be consistent when I'm doing it. So this first one right here is going to be 15 over 10. That's my first one. My second one, I'll use a different color. My second largest number is going to be 12 right here. And this one is going to be 8. So I'm going to have, this one is going to be 12 over 8. And then my last one that I have right here, let's do this in violet. It's going to be 6 and 9. So I'm going to put the right one is 9 over 6. Okay. So now I just have to simplify these ratios, and if they're all the same, it's a similar triangle. So I see in this one right here, a 5 can go into both. So this is going to equal 3 over 2. So that's that one right there, simplified. I can see in this one right here a 4 can go into both. So divide top and bottom by 4, and that's going to give me 3 over 2. And then this last one right here, again, a 3 can go into both these, divide top and bottom, and I'm going to get 3 over 2. So again, I see that they all come out as 3 over 2. Which means that each side is proportional, so these two triangles are proportional. So I'm going to write a similarity statement. So I'm going to write, whoops, let's see if I can make this into a triangle. Triangle, that's good enough. That's a triangle right there. Triangle, and let's put STU is similar. That's my similar sign, and this is where I got to be careful though. I have triangle. I just got to make sure they go in the same order. So the S is in between the black and the violet, so that's going to be black and violet. That's going to be X right here. Let's do T right here. T is between violet and red. V is in between violet and red. That's going to be V, and then that means my last one right here is going to be W. So that is going to be, my similarity statement right there. Perfect. They all have, they're all proportional, and then it's going to be similar. Okay. All right, here we go. So our third problem that we have right here is we're going to do a proof. Bum bum bum. Yeah, remember these. Okay, so so we are trying to prove that ABC is similar to PBM, triangle PBM, and we are given that these two lines are parallel. So remember, in a proof right here, let's switch this to black. We're going to have our statements, and we're going to have our reasons. And then we're going to separate these right here. So we're going to, dang it, why is it doing that? Whatever. Alright, so our first one right here is going to put what was given. So one right here, we are first given that MP is parallel to AC, and number 1 right there, that was given. Really messy, but it works. Alright, so let's just think for a second. What are we trying, how are we going to prove this right now? So if I'm looking at this right now, I know that these two angles right here, they're vertical angles. So we know those are the same. And now, why did it tell me that the two lines are parallel? Well, it told me that because we know that alternate interior angles are congruent. So we know that those two are the same. And if I have two angles are the same, we can use our AA postulate in order to prove the two triangles are similar. So that's exactly what we're going to do. So we're going to say 2 right here is, we are going to say that angle C is congruent to angle M right there. And then how do we know that? We know that because those are alternate interior angles. Number 3 that we have right here is, we know that angle, and we're going to write it CBA, is congruent to angle PBM. And how do we know that? Because we know that vertical angles are congruent. Vertical angles. And so now when I'm looking at this, it's always good, just like how we did that side one. Remember when you used to put it on the side right here? I would put these are an angle and an angle. And again, as long as we have two of those, well, let's close quick. Then we can be able to solve right here. So our step number 4 is we can now put that triangle A, B, C is similar, that's my sign for similar, to triangle PBM. And for right here, we can just put our A postulate. There you go. There's our proof. All right, we got one more problem left. All right, and then our last problem that we have right here, write down the question and then just write down these two triangles. So this is before rock climbing. Darius wants to know how high he will climb. He places a mirror on the ground and walks backward until he can see the top of the cliff in the mirror. What is the height of the cliff? All right, so if we are looking at this right here, we have two proportional triangles. Make sure you draw it. So if I'm looking at this one on the right here, this larger one, that is x, that's the height. And Darius' height right there tells me is 5.5. So I'm going to set this up as a proportion, and I did the right one first, the bigger triangle. So it's going to give me 34 over, and then this bottom one right here is going to be 6. So now I can just do cross multiplying, which is going to give me 6x equals, and then I have a calculator. We get 34 times 5.5 is going to give me 187. And then divide both sides by 6, and x is going to equal 187 divided by 6 is going to give me 31.16, and I get 6 repeating, so I just do the repeating sign right there. And that is my answer. That's how I set it up as far as a proportion. Okay. All right. Sounds good. Thanks for watching.